The US government spends about $20 billion every year cleaning up litter. The irony is, most of this money isn't actually spent on cleaning up litter. It's spent on trying to find litter, trying to detect it, trying to find people who can clean it, and buying resources to clean it. In addition to that, beyond just the US government, there are organizations like Keep America Beautiful and Adopt a Highway that work 24/7 in order to aid in trying to find litter and clean it up. So our goal was to try and find an easier, more efficient, and more effective way to clean up litter that is far cheaper than what's currently being done. And the solution we ended up landing on was using artificial intelligence and cameras in order to detect litter, as well as a mobile app for volunteers or government employees who are picking up litter so they can more easily detect, clean, and pick up this litter in order to make our communities a safer and more litter-free place. So now let's jump into how the system actually works from a technical standpoint. We've trained an efficient AI model on the Taco dataset, which is a large dataset of litter containing images. Once the model, which is running on a camera, it detects litter, it screenshots the image from the camera's video feed containing the litter, places a box around the litter, and uploads this image to our backend class server, where it's uploaded to our AWS S3 bucket, and the URL is stored in our MongoDB database, along with other information like the location of the detected litter. From there, we notify volunteers who have downloaded our app that a new piece of litter was detected. We show them the picture of the litter, which is pulled from our database, along with the location, which is also pulled from the database. And from there, the volunteer can head over to the trash, pick it up, and then mark off that they've done so on our app. So in other words, we have three key parts of our system. Each one of them is interconnected, and we essentially hope to be able to deploy this model to real-world cameras that are already functioning. The way we will do so is through something called Azure IoT Edge, and basically what that means is for any camera that's already connected to the cloud, of which there are thousands, we can basically deploy this model to the cloud, and then those cameras can pull the model onto themselves and begin running it through the Azure IoT Edge. And so in other words, this is a very scalable solution. It's very easy for us to deploy this model to thousands of cameras that already exist, and we don't necessarily need to just produce these cameras ourselves. But enough about the technical details. Now let's jump into a quick demo. We demo our model by setting up a camera which runs the model in front of a bunch of trash, and as you can see on the right, it is effectively detecting that trash. From there, the image is uploaded to our backend, and volunteers who have our app can see the location and the picture of the litter. What you'll also see is that the app is updating in real time. So in other words, volunteers can get the latest feed of what the trash looks like at the location. Once they arrive at the location, they can mark off that they're picking up the trash on our app, and once they're done, they can mark that off as well, and we'll record that on our app and will not show the litter to future volunteers.